Welcome to our lesson number 2 or session 2, the basic concepts in estimation. So the first topic is the transformation theorem. So given a normal random variable x with a mean mu and variance sigma squared, then z is equal to the x, which is the observed score, minus mu all over by sigma. So I gave you an opening activity last time and you sent me your data, and for that particular activity I will show you the computation of the standard deviation using the SPSS. Let me just continue here with letter A, which is the standard error of the mean. So if a sample is drawn out from a population n times, so you will draw a sample from a population for several times for the nth time, and each times the mean of each sample is computed, we would compute n means. And if this were to be plotted in a frequency distribution, the distribution would be referred to as a sampling distribution of means. So its relationship to the population mean is equal. Remember, your sampling distribution of means or your sampling mean is equal to your population mean. And by symbol, it looks like this one. Alright. So if we compute the standard deviation of the sample means, then we have standard error of the mean. And by symbol, we have sigma sub x bar. So in formula, the standard error of the mean is equal to the sigma, which is our standard deviation, all over by the square root of n, or rather, the standard error of the mean is equal to sigma all over by the square root of n, wherein sigma is equal to the standard deviation and n here is equal to the number of sample size. So there's a question here. What happens to your standard error of the mean when we use a sample to estimate the mean of a population if the sample size, which is our n, is increased from 50 to 100? Alright, so it says here, compute the standard error of the mean of the data you collected in the opening activity. Compare with other groups. In order for us to compute for the standard error of the mean, we need to have the value of the standard deviation. Okay? So, let me write that one. We are asked to look for the standard error of the mean, which is actually equal to the standard deviation all over by the square root of the sample size. Okay? So we need to look for the value of the standard deviation first because we only have here the value of the sample size. Okay. So by showing you the data, this data actually come from your data last time. Okay, so F stands for the group of Mr. Francisco, and V stands for the group of Mr. Verhel. It happened that your group members aren't the same. I mean, the sample size is not the same from Mr. Francisco and Mr. Verhel. So what I did is, I only got 12 from Mr. Francisco and 12 also from the group of Mr. Verhel. So I go here to analyze, and then I will choose descriptives, and then I will input F and B in the variables and click options. Click, I don't need to get the mean, I only need the standard deviation because we need the standard deviation to get the standard error of the mean. Okay, I will unclick or uncheck rather minimum and maximum because I only need the standard deviation. Click continue and click OK. Alright, so as you can see here guys, the group of Francisco has 22 standard deviation and the group of Verhel has 8.05979. So if we are going to compute for the standard error of the mean using the two given, let's go back to the whiteboard. Okay, so we are asked to look for the standard error of the mean, okay? So let me just clear this first. Oh yes, because I'd like us to write first the given. So what are the given? The given we have VG or Verhel's group versus FG, the group of Francisco. In the group of Verhel, we have the number of sample size is 12 and the standard deviation computed is actually 8.06. While on the other hand, the sample size here is 12 and the standard deviation computed is 22.18. So you can see the data in Francisco's group is actually varied because their standard deviation is larger. Okay, so we are asked to compare for the standard error of the mean of these two groups. So let's have this one. So the standard error of the mean has the formula standard error of the mean is equal to standard deviation all over by the sample size. So this is now equal to 8.06 all over by square root of 12, which gives us the answer. The answer now is actually 2.33. Okay, so it's 2.33. I will encircle that one with color red. Alright, so this is my first standard error of the mean. On the other hand, I will compute for the standard error of the mean of the Francisco's group. So, same formula. We have, okay, there should be a bar there. Standard error of the mean is equal to standard deviation or over by the sample size, square root of the sample size. So, we have here 22.18 all over by the square root of 12, which gives us the answer 6.40. Okay, I will also encircle that one. Okay, so let's now compare. So observe the data and let's fill in the blanks. As stated in the lecture guide. So the relationship of your standard deviation and your standard error of the mean. So let's take note of that. Okay, I will choose blue. The relationship of standard deviation and standard error of the mean is actually direct. Okay, what does it mean by that? When your standard deviation is increased, your standard error of the mean is also increased. So conversely, decreasing your standard deviation would decrease your standard error of the mean. Okay? Alright. On the other hand, if you look at your formula, the relationship of your standard error of the mean and your sample size is indirect. This means that if your sample size increased, your standard error of your mean will decrease.